A couple things about the actual video lesson from 9.2. Thank you to those of you that pointed this out to me. For the assignment comments, I don't know what I was thinking when I did this question for letter B. It's number 5, letter B. So for those of you that have your class notes out with you, if you can make sure that you change this, because a lot of you I saw just copied the answer that was incorrect. The combination of 52,5 I know is 2,598,906. That's one of the most common numbers that we continue to use when we use cards. And for some reason, I changed it to like 270,725. Quite a few of you caught that, so thank you. But for those of you that didn't actually do the calculation in your calculators, make sure you do have it typed or written in correctly in your notes. And now that that's probably all done, what I do want to go over is your homework assignment. Thank you guys for always correcting your homework. It really does help because I kind of already have an idea of which questions to go over with you. I'm going to pull out my calculator and we will go ahead and get started with question 1. So an election ballot asks voters to select 3 city commissioners from a group of 6 candidates. Your aunt and your father are running. What is the probability that either your aunt or your father will become a city commissioner? So for this question, hopefully you recognize that it's very similar to a question you've had before. The difference is now, of course, it's your aunt and your father running as opposed to, or it's your aunt or your father as opposed to and. So we have 1, 2, 3, 4, 5, 6. We're still picking a group of 3 people from this, from all the 6 that we have. So the probability of your aunt or your father would be equal to the probability of aunt plus the probability of our father, not B. So from this point, what we would do is find how many different ways can my aunt be chosen for this group of 3. The denominator is the combination of the 6 people that we have. How many different ways can we select just any 3 of them? So again, that's the same denominator we had last time. The numerator is the event that my aunt is chosen. So how many different ways can that happen? Well, it could be my aunt with the remaining people would be father, person 1, 2, 3, and 4. So it could be aunt with person 1 and 2, aunt with person 1 and 3, aunt with person father and 1, etc. All those different combinations would be the aunt, which is 1, times the remaining 2 people that she's paired with. So it would be the combination of 5, 2. Of the 5 remaining people here, how many different ways can I select 2 of them to fill these spots? Then I'm going to move on to my father. So the probability my father is chosen, well, I'm going to fix my father in this spot that my aunt was originally in, and then find all the different ways that could happen. So it could be father 1, 2, father 1, 3. Of course, it can be my father again, but it could be father, aunt 1, father, aunt 2, etc. So that would be 1 for my father times the combination of 5, 2 divided by the combination of 6, 3. And we know that since the word or was there, we're going to be adding these 2 probabilities. Well, there's actually 10 different ways that your aunt could have been selected out of the 20, plus 10 out of 20. And obviously that doesn't make sense because it's not 100% likelihood that your aunt or your father is going to be chosen. And the reason for that is because we have overlapping events. Right here, you notice that your aunt, father, and 1 in a different order was already counted. So what I have to do is subtract out the intersection of both my aunt and father being chosen. The 5 came from the remaining 5 people here and how many different ways we can select 2 people to fill those spots. So the 1 is like guaranteeing that my father is going to be in that spot. And then the combination of 5, 2 tells me how many different ways I can fill these 2 spots with the remaining 5 people. And now the combination, or right here, the probability of my aunt and my father being chosen would be the probability we found to last class. Of the 6 people, how many different ways can I select 3 of them? And my numerator was, if I fill my aunt and my father in these two spots, how many different ways can I fill this last spot? It would be with person 1, 2, 3, or 4. So it would have been 1 times just 4, or the combination of 4, 1. So then I would subtract out 4 divided by 20, and then you end up getting 16 out of 20, which is equal to 4/5. So then from here, another thing I want to mention is this last part be true. So what I did was I went back and adjusted the slides to show you all 20 different combinations possible. Then from here, if you wanted to write all of them out, go ahead and do that. You'll end up coming up with the same answer. My aunt being chosen would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 out of the total 20 that my aunt is chosen. Then what I can do is figure out how many ways my father was chosen. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as well. And my hope is that you see I circled these 4 twice. So instead of counting them being like 8 out of the total 20, I want to subtract out the 4 out of the 20. So hopefully, like visually, this makes sense why we are subtracting the 4 out of 20. And again, a combination is a faster formula that we can use so that we don't have to draw out 20 different like situations. 3 is the other homework question. You have Sylvester in a music competition with 14 other musicians. What is the probability that he is chosen last and his 2 best friends are chosen first and second? I'm going to show you 3 different ways how to do this, just to show you that there are always so many ways to solve any of these types of problems. Again, there's not just one way to do pretty much any probability question. One way you could have done this is to use a combination. You could have also done a permutation as well. So then you have person 1, person 2, you have these people in the middle, and then you want Sylvester to be last. So one way using a combination, how you could have done this is saying, what is the probability he's chosen last? Well, it's just 1 out of 15. There are 15 people total. You want to fix him in that very last spot. Then you want his 2 best friends to be chosen first and second. So this could be best friend 1 and this could be best friend 2, or you can switch them around as well. It doesn't really matter. They're just being fixed in those 2 spots. So then you would multiply it by just the combination of 14. Since we took out Sylvester now, we're just worrying about the remaining 14 people here. And how many different ways can you just select 2 of them? By doing this, you're just saying it doesn't really matter the order that they're chosen. So I don't have to take into account there's 2 different ways that could happen. There's just the one way that they could happen where you're selecting both of them out of this total group. And then it would end up being 1 out of 15 times 1 out of 91, which ends up with the 1 out of 1,365. So that's one way, just using a simple combination. Another way you could have done this is to use a permutation. And for a permutation, what you could have done is the same idea where you have 1, 2 best friends, you have the remaining 12 people, and then you have Sylvester last. So these are the 12 people. This is the best friend 1. This is best friend 2. So if you take into account every single person that's here, you are finding an arrangement of 15 different people. So the permutation of 15, 15 would be the denominator. The numerator would be how many different ways can you arrange and get this exact event to happen, that it's best friend 1, best friend 2, the 12 different people being arranged, and then Sylvester. Well, it would be how many different ways can you arrange these people? So the permutation of 12, 12 would be all the different arrangements here, but I would have to multiply this by 2. And the reason for that is because this is one of the like events, I guess. And then if you switch the order of these, it would be best friend 2, best friend 1, Sylvester still at the end, and then the permutation of the 12 people right here. And you would still end up with the same answer when you reduce it. Hopefully one of those explanations made sense to you. I think those were the only homework questions that were asked. For number 6, let me actually pull that up so I can answer your question. Oh, and Erin, that was actually the last way that I did not mention. Yes, you could have also had the permutation of 15(3), and then in the numerator, it would be 2. And this is because you're fixing these two best friends in the spot. Sylvester is last, and it really doesn't matter with the arrangement of the remaining people. So you're just wondering how many different ways can you arrange 3 from the 15, and that's perfectly fine as well. And so no one else had a question on that in my other classes, and I didn't really see anyone get that incorrect when I looked at your homework. So I don't know how that many stars came out for that. But we will go over number 7. So during their careers, Kobe was an 84% free throw shooter and Shaq was a 53% free throw shooter. If they each take one shot, what is the probability that they both make it? So the word both implies that it would be Kobe making it and Shaq making it, meaning that you're going to multiply these two probabilities. So it would just be 0.84 times 0.53. And again, this word both here, yes, does imply that they are both making it, so and. Okay, so I did want to also go over the rest of your classwork notes. As I looked through it, majority of you were getting it correct, so I didn't think it was necessary to create a poll for today. If you can check your answer for number 10, letter B, the probability they will be half upperclassmen and half underclassmen. You should have gotten this as your result. It will be a mix of multiple choice as well as fill in the blank. And for the fill in the blank, I mean, the numbers won't be this large for the most part, but it will ask you for a simplified or reduced fraction. So that is how you would leave your final answer. For number 10, letter D, if you can also check your answer for this question. Said earlier, this is going to be a shorter conference. I want you guys to have some time to relax, bake a little bit, or I don't know, tan outside because it is kind of hot today. Just a reminder, yes, you do have a quiz next class. It'll be after class ends. It'll be open until like 11 p.m. or so.